Hi everyone, we need to move on to a new chunk, and what we specifically need to look at is what do we do when exponents won't allow us to get down to a single variable. So we looked at if we start with only one appearance of our variable, what do we do? And then we looked at if we have our variable showing up more than once, but we can get it all on one side and combine down to get one variable. And now we need to look at what we do when we have, as you see in this example, an x squared and an x floating around in different terms. They're not like terms, so we can't combine them. You can do things like factor out an x, and you still have two x's, and there's no way to get down to one. Sometimes people will try, so I don't like that, getting that x squared by itself and then square rooting. This doesn't help us because we still have an x over here, right? There's still two x's. So we have to basically come up with some new tricks, and there are 3 of them that we'll use. So this first chunk is just factoring will be our trick. So I showed you factoring that doesn't work, but I will also show you factoring that does work. So I'm actually going to backpedal and give you the key to solving this problem first, and then we'll jump into some. So there's this fact about numbers called the zero product property. And I don't care if you remember what it's called. I promise I'll never quiz you on the name of it. But I want you to be really clear on what it says. It says if you multiply 2 things together and you get 0, so if, then a equals 0 or b equals 0, and that would be a mathematical or. It could be just a is 0, it could be just b is 0, or it could be both are 0. So really what this is saying in kind of a fancy way is pretty simple. The only way to multiply 2 numbers together and get 0 is if at least one of them is 0. There's no other combination of numbers that you multiply and get 0 unless one of them is 0. What I want to be really clear about is this doesn't hold. So let's say, what about a times b equals 1, or it could be 5 or 7 or whatever. We don't know anything. So just for example, we could have 1/4 times 4. We could have 1 times 1. We could have 2 times 1/2. We could have -30 times -1/30. So, I mean, I guess we know something. We know that the numbers are reciprocals, but we absolutely cannot draw any conclusions about what A is or what B is. So this property is very, very specific to 0. So basically what we're going to do is we're going to say, okay, well, if we can factor, if we can set this equal to 0 and factor, then we can claim that the solutions happen if either one of the factors is 0. And the reason this is helpful is because it allows us to break one messy equation up into 2 simpler equations where we can get down to a single variable. Okay, so let's jump into it. My examples. So I started off with one that's actually already set up for the zero product property. This is a product, right? I'm multiplying x by x minus 3 and I'm getting 0. The only way that could possibly happen is if either factor 1 x or factor 2 x minus 3 are 0. So this is going to allow us to take this messy quadratic equation. It's quadratic because it has a second power in it, and that's the highest power. So we're going to take that first factor and set it equal to 0. And we're going to take that second factor and set it equal to 0. So the original statement is true if either of these simpler statements are true. The first one's really done, right? We don't have to do anything. If x is 0, then you'll have 0 times -3, and that is 0, done. The other one is really simple to solve, and generally they are pretty darn simple, maybe 2-step equations. We can add 3 to both sides and say, okay, if x equals 3, then we get 3 times 0, which is 0. So those are our solutions. X is equal to 0 or 3. Quadratic equations don't have extraneous solutions. Factoring, splitting it up into two equations, none of those steps are going to introduce an extra solution that's not valid. So if you're checking your answers, what you should find is either they check, which means you did it right, or they don't check, which doesn't mean it's extraneous. It means you made a mistake either in your solving or your checking. So try to be clear. I know that gets confusing as we go, but there's no step happening here that would introduce an extra solution. It is possible for a quadratic equation to have no solutions, but that just means you won't find one. You'll get started and you'll get stuck somewhere along the way. So we'll see that in later sections. You don't really see that with factorable. If it's factorable, it's going to have solutions. It can have only one solution. Okay, so let's try another one. That one was really nice because it was already equal to 0 and it was already factored. My big warning before I move on is this first one, this lonely x, people like to just forget about those. For one thing, people forget to try and factor out a greatest common factor, so they won't get it factored that way. But even when they get it factored that way, they want to just pay attention to the x minus 3 equals 0 and forget about the x. So don't forget about. Okay, number 2, not really so nicely set up for me. So what I'm seeing is it is quadratic. I see that r squared. A quadratic may or may not have an r as well, but it definitely should have the square on the variable and no higher power on the variable. So if I want to use my new trick, I have to have this thing equal to 0. So for quadratics with more than one variable, key step, and this will be true for other methods that we use to solve quadratic, is setting it equal to 0. From there, you have to be able to factor it to use this method. So if you run into one that's not factorable, yell at me because I messed up. It should all be factorable on this homework. So I'm going to factor out the greatest common factor. Don't forget to look for that. R squared minus 2r plus 1. That's actually really nice. And then I'm going to factor the trinomial, and that's actually really nice as well because that factors, I need factors of positive 1 that add up to negative 2. That's negative 1 and negative 1. This is a perfect square. So I really have 3 factors. You can write it out that way if you'd like to, but one of them's repeated, so it doesn't really give me any extra information. So either way, you can write it either way. So looking at this one, based on what I did in the last one, I'd be inclined to say, well, I have to set that factor equal to 0. And you can, and it's not wrong. But what you should immediately conclude is that that's impossible and just throw it away. 7 doesn't equal 0. That's not telling me a solution to the equation. There's no way to use that factor to make the statement 0. My other 2 are r minus 1 equals 0, or r minus 1 equals 0, and you absolutely do not have to write that down twice because they're both going to give me the same answer, which is r equals 1. So you should see that often quadratics that are factorable in particular have 2 solutions, but it is certainly possible if you have a perfect square for that to have only 1 solution. And as I said, we'll see later that you can definitely also have no solutions. It's just not the case with factorable quadratics. If it factors, it has solutions. Okay, getting even a little bit messier. This is kind of exciting. It looks like it's going to be exciting because it is in a factored form on the left-hand side, but it's completely useless because we can only draw conclusions about products if we know they're 0. If I know this is equal to negative 6, that doesn't tell me anything. I could have negative 2 and 3, I could have negative 3 and 2, I could have 36 and negative 1, 6, I could, infinitely many possibilities. So there's no way to narrow it down based on saying the factors, the product of the factors is negative 6. So we're going to go back to our tools that we've been using, the factoring tool. We need to first set it equal to 0, then get it factored. So I can set it equal to 0 pretty easily by adding 6 to both sides. But notice this is a product right here, but the big operation is now addition. So this still isn't in a factored form. So really what I'm going to need to do is multiply through the parentheses. My variable's stuck in the parentheses. I can't really do anything about factored until I deal with that. So I'm going to multiply through, and I get 6b squared minus 13b plus 6 equals 0. So now I'm back to my usual trinomial, ax squared plus bx plus c sort of thing. And I can try to unfoil, and I'm not liking this one already, but let's see if I can get lucky. I'm going to guess that I want a 3b and a b, or I'm sorry, and a 2b. So first I need factors of 6b squared. And then, ooh, I think I can get lucky. If I make this 3 and this 2, and they're both negative. So my first is the 6b squared that I needed. My last is the 6 that I needed. It's the inside outside that I'm worried about. So always double check yourself or you're going to get bad answers. The inside is negative 4b and the outside is negative 9b, which does in fact add up to negative 13b. So I think I got it. Okay, so again, why is this helpful? It's helpful because in the original statement, I had two b's, and there is nothing I can possibly do when there's a b squared and a b to combine those and have only one b. So what I have to do is factor and then split this up into two linear equations, two simpler equations that do only have one b. So I can say this product could only equal 0 if either the first factor is 0 or the second factor is 0, or again, both could be 0. That's actually what was going on in the last problem where we only got one solution. R equals 1 made both factors equal 0. Okay, so these both need a couple of steps to solve, but nothing too bad. For equation number 1, I'm going to add 2 to both sides. So I get 3b equals 2. I encourage you, as you get comfortable, to not write the work in on every step. It's fine to do to help you keep track, but you actually get, so there's this funny mathematician thing where we like our solutions to be aesthetically pleasing and nice and simple and concise, and so it kind of makes a little bit of a mess when you write everyone in, so we do try to get to the point where we are in our head saying I divide both sides by 3 and I get 2/3 and not having to actually write it. So I promise not to be offended if you do write it, but if you're feeling comfortable, make it pretty. Equation number 2, I'm going to add 3 to both sides, and then I'm going to divide both sides by 2, and I get 3/2, and those are my solutions. So again, it never is a bad idea to check, plug back in and make sure that works, but you would never draw the conclusion that you should throw a solution away. If it's quadratic, you either did it right or you did it wrong. You don't get extraneous solutions. You don't get a solution and then throw it out. Okay, one last one. Again, this is really tempting. I'll see people say things like, oh, well, 2k plus 3 could be 5 and k minus 2 could be 3, and that's possible, but there's infinitely many other possibilities, so that doesn't really help us narrow down the solution. So what we want to do here is the same thing. If we're going to try and solve by factoring, and right now that's the only tool we have, so lucky you, if you see something that looks quadratic, you can go straight for factoring. Ooh, maybe I should mention, maybe you're not spotting this either. What I'm kind of thinking in my head is if I multiplied that out, I'd get a 2k squared minus 4k plus 3k minus 6. That's how I'm thinking it's quadratic. So even though I don't see the second power, I can tell that I would multiply k's together and get a second power. Okay, so this is great. It's equal to 0, but now it's not a product, it's a difference. So just like last time, I am going to have to multiply this out, and you can just do that first if you would like as well. A lot of people have done a little of this solving by factoring before and know that. So now I'll take what I said over there. I had a 2k squared, and I'm going to go ahead and combine and say minus k minus 6 minus 15 equals 0. And I can combine once more. Negative 21 is what I'm getting. So I'm going to go ahead and try and factor that. So the first one at least is easy. I get a 2k and a k. And then I need factors of 21, so I'm thinking 3 times 7, and I can give 1 a negative. If I want to get a minus 1k, I think I better put the 3 here and the 7 here, so that my outside is 6k, and my inside is 7k. And if I make that a minus 7k and a plus 6, there's my negative 1k in the middle. Okay. So finally, I get to split this up and say, all right, well, the only way a product is 0 is if one of the factors, or both, are 0. So I get two simpler equations where finally k only appears once. For equation number 1, I'm going to go ahead and add 7, and then I'm going to divide by 2. For equation number 2, I actually get off easy and just have to do one step. I need to subtract, and I need to get k equals -3. So in general, we're anticipating that at least there's a possibility of getting 2 solutions, but again, it is possible to get 1, and later we'll see examples where we get none. Okay, thanks for watching.